Uh, Good morning, dear students. Am I audible?
Yes, sir.
Yes, sir.
Yeah, thank you for your response. We'll start today's session. Okay, today we have on the class agenda two things. One is to discuss about source routing and learning bridges. The uh, uh, the second part of the class, we discuss about the revision of module 1, because we are supposed to have a test, internal test during upcoming week. So we will have a quick revision of the test. So we will certainly work on the things, right? Okay. So we have been discussing from past 2 3 days, mm, okay, regarding switching techniques. So the switching techniques that we have seen, the first one is datagram, second one is virtual circuit that we have already discussed. Now, the third one is source routing. Source routing is less common used, but it is having a lot of useful applications. So we are targeting the third approach, that is source routing now. And of course, look at this diagram. The same example which I have been used in other two routing switching techniques, source routing. By the name source routing itself, it is understood that, so what happens, the source will create the path, decides the path, and in which path it has to move. Everything will be written in the header of the frame, and the frame will be sent. So before starting itself, the frame header contains the information regarding the route. So source will direct how to go in the network. So that is called source routing. This is the third approach of switching techniques. So all the information regarding the network topology is required to switch packets across the network, probably that is being provided by the source host itself. And here are various ways that there are various ways. We'll discuss all those ways. But one of the common way that is, we are using, the simplest way is to assign the number to each routing switch, and it will be sent. So this number is present in the header. So this is one very important thing that you should understand. So inside the header, what is there? The number. There are some numbers placed. You can see 301 is placed, 130 is placed, 013 is placed. So what are these? The next question that now comes to our mind is, what is this and how exactly it works? The simplest way, that you should, this is the simplest method of source routing. Initially it will hold the from the left to right, it will hold the information from left to right, that one means it has to go to switch number one. That's all. The packet has to go to switch number one. Once it reaches the switch number one, what happens? The switch one will rotate the header. Rotate the header. Automatically, what happens? One will come. It occupies. It rotates. It come here, and it becomes 130. 130. And what is there in the next? This one in the 130. So zero is there. That means the switch has to go to next switch, that it has to go to next port, that is it has to go through next port. Next port is through zero, zero port. So port number zero, so it has to go to the next switch, and it has to go through the zero port. Yes, from zero port it has to reach to the next one. So next one is 3. So 3. So when it reaches here, so again rotation happens and it forwards. So what happens when it forwards? It contains the information about what is the next port number it has to move out. It has to move out. So this is the information that generally it holds. So you can see that the same thing. So this will be rotated. The port numbers will be rotated, and so based on the port numbers, so this is the port. It will tell on which port it has to go out from switch 1, and after reaching switch 2, which is the port that it has to go to next. So it is 0 is there, and what is the port that it has to reach the other switch, that is 3. So initially what happens, the source itself, the source host itself will come to know the topology of the entire network, and it will know what are the participating switches, and in the participating switches also. So what happens, what is the port number in which it has to go out, all those information are there in the header. So in the case of virtual or datagram circuit, datagram switching or virtual switching, every time the switch used to take decision, but here the decision is made only once, that is from the source. Source host itself will make the decision, right? So that's the thing. And of course you can see, so one is the host number, one is the port number in which switch 1 has to transmit. So once it is done, it will rotate. So next is 0. 0 means 0 is the port number in which it has to transmit. Next is it rotates, and 3 is the port number it has to rotate. So it will reach the destination A to B. So you observe that for each packet that arrives on input, the switch would read the port number in the header and transmit the packet onto the output port. That's all. So it will just transmit once it reaches the switch. As the switch will just transmit the packet in the output port. That's all. It will transmit to the output port. It will never calculate anything, never think of which side it has to go. Everything, port number, everything, it is there. Since it is transmitting into the port number 1, it is understood that it will definitely reach switch 2. Switch 2, what it will see? It will see its next digit. What is there in the next digit? 0. 0 means it will transmit automatically in the 0 port. Switch 2 will never take any decision. Every decision is made at the host itself, source itself. So source host itself. So that is the thing that you should understand. Further, however, since there will in general be more than one switch in the path between the sending and the receiving host, the header from the packet needs to contain enough information to allow every switch in the path to determine which output the packet needs to be placed on. So this is how switch will decide where it has to go out. Switch will decide where it has to. The switch will see, and it will just transmit. So that's the thing. And of course, one way to do this would be to put the order of the list of switching ports in the header and rotate the list so that next, so that the next switch in the path is always at the front of the list. So that's what rotation will be done, so that the next switch in the path is always at the front of the list. So that's how it has to be done. And there are that's how it reaches. That is what we call it as source routing. Source routing is very simple. And other forms of source routing are written like this: rotation. What we have seen just now is the rotation. Rotation 1 we have seen. The second one is what we call is a stripping. Stripping means after reaching one station, it will remove the last. What is there, it will remove. After reaching the next switching station, it will remove this. After reaching the next one, it will remove the next one. After reaching next one, it will strip. Strip means it is just removed. Third one is what we call third approach of source routing is called pointer approach. In pointer approach, what happens? A pointer will be used if it is moving towards first switching station, it will point it like this. For the subsequent, it will be pointed. For the next one, the pointer will be pointing to the previous one. And finally, the last one will be pointing to D. So like this, every time it moves. So these are the, what you call it as various switching, ports, and these ports will be certainly being pointed by a special pointer. This is pointing. So there are three ways. So one is rotation. Rotation I have explained. Stripping is very simple. It will keep on removing. Once it goes to switch one will remove the front. Yes, it will remove. Next, when it forwards it. Next, when it reaches to switch 2 will remove. Next, when it reaches switch 3 will remove. So it is just like that. So finally, when it reaches the destination, there will not be any content in the header. So because each switch will remove one bit. So that is what stripping is about. Pointer will be pointing. Initially, it will be pointing the last element, and later when it switches, next element. When it switches, next element. When it switches, next one. By the time when it reaches the destination, the pointer pointing to the last element. That is the concept that you should understand. So these are all the concepts that we have to understand with respect to source routing. Next, we have bridges and switches. So bridges and LAN switches are two different terms. We generally call it as bridge only. LAN switches are also called as bridges. So observe here, we have two LANs. The first LAN, there is one LAN, there is another LAN. So two LANs can be connected using a bridge. So they are connected through a bridge, and of course, since bridge connects similar networks, so it is used like an extension extension box of a LAN. So whenever you want to extend some more hosts in the LAN, so it is possible. And I have already said the maximum number of hosts in a LAN is 1024. Beyond 1024, if you want to extend, so you have to put one bridge, you connect again to another LAN. So it is just like that. You can certainly have a thing. So very important. We begin by considering a class of switch that is used to forward packets between LANs, such as Ethernet. Such switches we obviously known as LAN switches. LAN switches, it is also called as LAN switches. Bridges are also called as LAN switches, and also been referred as bridges. They are very widely used in campuses and enterprise networks. And of course, so a collection of LANs connected by one or more bridges is usually said to form an extended LAN. So that is one of the very important thing that you should know. If you want to have an extension of the LAN, so you have this is the only technique that we have. In their simplest variant, bridges simply accept the LAN frames on one input port, and it will forward it to other input port. That's all it does. They are also called as repeaters. LAN bridges or LAN switches are also called as repeaters. They just accept, they repeat it in the other port. That's all. So they forward it in the other port. That's all. And of course, how exactly it works? That's the biggest question. So the first optimization we should make to a bridge to observe that it need not forwards all the frames that it receives. Very important thing. It will not forwards all the frames. It will not forwards all the frames. It knows only the frames that are meant for only XYZ. It has to be forwarded from this LAN to this. If the frame is towards ABC, only from this LAN it has to forward to this. That's all. So if it is between A to C, why it should forward it? It should not forward it. So A to C are in the same LAN, so it will never, even though packet comes here, it will never forward. It will just send it back. So it will send back if it is for A to C. Similarly, suppose I am transmitting from X to Y. So again, since it is in the network, so the packet will move in all direction. So once it reaches the destination, the bridge, so it will simply take a decision and it will forward it back. So this is what that we should understand. Not all the frames are forwarded. So observe that very important thing. Frames that are received in the bridge are not forwarded. All the frames are not forwarded. So consider the figure. So where suppose A wants to address to B on port 1. So there is no need to forward bridge to other port. So if it is between A and B, if A is transmitting to B, even the packet comes, even the frame comes to bridge, it will never forward. So that is one intelligent thing that we should observe. And the question is, how does bridge come to know about this? The answer is here. So each bridge maintains a forwarding table. So forwarding table maintains the, uh, maintained at the bridge. It has the host and their respective ports. So ABC are available in port number 1. So XYZ are available in port number 2. So they are connected to port number 2. That's all. Very simple. So if the B is coming, B is the destination, and if it is coming from A, so both are in the port 1 only, so it will never forward. If A you are sending and you are transmitting to Y, so A to Y, so what happens? Y is present in the port 2, A is present in port 1, so it will automatically forwards it. So this is how exactly works. And whenever a bridge receives a frame from port 1 that it is addressed to host A, it would not forward the frame to frame out on the port 2. There would be no need because host A would be already directly received the frame on the LAN which is present in the port 1. So anytime forwarding address to A that was received on port 2 would only transfer from one frame port to another frame, one port to another port. And no one actually builds this bridge table. Actually, whenever bridge boots, what happens? Bridge will automatically send a hello frame to all the nodes in the port. So we call it as echo frame. So once it touches the destination port, the echo frame will come back and hits and tells, oh, in this port number A, B, C are there. So because echo frame, it is sent to both the port, sent in both the port by the bridge when bridge boots up. And with this echo frame, bridge will easily come to know, oh, port 1 has ABC, port 2 has XYZ. Oh, if there is a, source and destination address are there in the port 1 itself, I should not forward. Or source and destination are both in port 2, I should not transfer. If the source and destination are there in the different ports, different port networks, then only I should forward. That is what the bridge has learned through this forwarding table. And forwarding table contents are filled automatically by the bridge. So when a bridge first boots, the table is empty. Entries are added over time. So this is what has to be understood. Next class we will discuss spanning tree algorithm that are followed very much in bridges. Of course, That's all for today's class. In fact, the second part of today's class, I had to discuss about revision on module 1. So the entire class recording is available in this website, and notes and materials are available in this website. Thank you. So now we'll make a small revision of module 1. Hope everybody you have module 1 notes. If you have module 1 notes, please have it in your hand so that we'll discuss one by one. So the notes consisting of 25 pages. So entire notes is consisting of 25 pages. The first part is about the definition of a computer network. So computer network is a collection of computers, printers, and other equipment devices that are used only for communication with each other. So their main purpose is the communication between each other. Next comes the applications of computers, networks. So business applications and home applications. When we met in the class itself, we have discussed all these things. The business applications and home applications. Business applications are related to the resource sharing, virtual private network, client server model for most of the transactions, client server model, web applications. Most of the web applications are business applications. Communication medium like emails, chatting, VoIP, voice over internet protocol, video over internet protocol. What you and me, we are enjoying now, the distance learning through Zoom. That is one of the example. IP telephony, video conferencing, desktop sharing. So I'm sharing my desktop. You are able to see. Same way I can hand it over remote desktop. I can control any computer. So e-commerce, electronic commerce is also one of the application. Coming on to the home applications, connectivity, main job of home applications are connectivity. So you want to connect your TV to the internet and watch a YouTube channel or Netflix or Amazon Prime. So for and not only that connectivity. So I want to connect my TV to my mobile to my computer or mobile to my printer. So just like that. So you can certainly have with the invent of IoT, Internet of Things. Today, many devices are connected to internet and home, especially home utilities are connected to internet, and of course online libraries, peer-to-peer communication. You want to send, you want to chat, you want to do video chatting, audio chatting. So all those things you can certainly do it as an this one application. IPTV, so internet protocol TV. So where you can certainly do gaming, many games you can certainly do. Ambiguous computing, so computing embedded in our day-to-day life, radio frequency, uh, networks, RFIDs, certainly we use. These are all the components of applications of computer networks. Further, when it moves, requirements. So in order to build a computer requirement, what are the essential factors that are, we have to consider? First one, perspective networks. What is that you are taking from the network? Second one, scalability of connectivity. As the number of users increases, the network should support. Cost effectiveness. Cost effectiveness means, so resources are there, network resources. If only one person is using, it is not being used properly. If multiple people are using, and if they are really making use of full use of it, so then, so if you consider one example, if you have a broadband internet link which is of 5 Mbps, and if you are using only so what happens, the entire 5 Mbps you are not using, you're using only 0.5 Mbps. So what about 4.5 Mbps? It is goes waste. So that is how, that's why what happens, you ask cost effective resource sharing. So what happens, there will be a technique, there are many techniques that will be followed. in order to efficiently share your network resources, make your network more and more effective. So that is another thing. And support for common services. Support for common services in the sense there may be a lot of services available through internet, through network. So all those services has to be supported. Manageability. The network, when you build, the network should be manageable. That is one very important thing. The first one, perspective, design perspective of computer networks. Let us see what is this. So whenever you are designing a computer network, the first and foremost thing, there are three people come into play. One is application programmer, and another one is network operator and network designer. So you have to build a network in such a way that, okay, how programmer should use this computer network. So what he wants according to his programming components, according to his programming this one. So what he wants, so accordingly it has to be there. And network operator, how network operator is one, certainly, how exactly network operator will look into the network, what he wants according to this. So by looking into application programmer, so generally what happens, application programmer requires only to serve a network, to serve his or her application needs. For example, he wants a guarantee that each message of the application should be sent, delivered without error, and it has to be reached, of course. And another thing is they need to connect to the network without any problem. The network operator, he is not worried about whether application works or not. He is not worried about. His main duty is easy to administrate. So he looks into how exactly he can manage, he can easily administrate. So this is, and also easily configuration, easy account usage, accountability for easy to generate bill. So all these things he has to just consider. Further, when we look into network designer perspective, network designer would list the various properties like cost-effective design. For example, network resources are efficiently shared. So how he can improve the performance of the network. All these things that he certainly looks into it. Second component requirement is scalability. Scalability is nothing but how it can be enhanced. So if the number of users today, only 10 users are there, okay, no problem. Network can support 10. If tomorrow all of a sudden 20 comes, so 20 users. So it is just like that. And some of the definition, what is a link? Link is nothing but it's a physical medium between the computing devices. We call it as nodes. So point-to-point link, where you have one computer is connected to another computer, we call it as point-to-point link. And multi-access link, the same link, it has been accessed by multiple people, we call it as multi-access link. Normally, wireless is an example of multi-access link. And we also understand switched network. Switched network in the sense computers are connected, computer networks are connected using various switches. So these switches are generally used to interconnect multiple networks. So we call it as switched networks. So there are two types of switched networks. We call it as circuit switched and packet switched. Packet switched is also called as a datagram switched. So wherein the data goes as a packet and it will reach the destination independently. Circuit switched, mostly employed like a telephonic system, where it has to be a circuit or a particular path from source to destination is assigned initially and it is transmitted. So today what we discussed, the source routing is also one of the example of circuit switched. And a switch is actually interconnection of many networks. So we call it as a switches, and their primary function of a switch is to store and forward the packets or frames. And of course, so which is there are, you can have point-to-point link switches, or you have multi-access link switches, or switched networks. So can be used. And if you have a very complex network, the complex network is represented by an abstract, diagram. We call it as a cloud. So, cloud is an abstract, complex network that is represented. We call it as cloud. And two different clouds can be interconnected through gateways. We call it as interconnection of networks of networks. We call it as internet. And in order to do this, every computer on the network requires an identity. That identity, we call it as an address. Address is actually a byte string to identify the node. So there are two types of addresses. One is physical address. Physical address is nothing but the MAC address. It is imprinted on a network interface card, NIC card, and it is available on all the computer devices itself, computing networking devices itself. Another one is, we call it as configurable software address, software enabled address. We call it as a virtual address. Virtual address, or the software address, we call it as IP address. That is that can be easily configured. You can change, you can allocate dynamically, but physical address is fixed. Finding a particular computer on the network using this address, okay, finding a particular computer using this address, we call it as routing. So routing is a process where you are systematically finding that particular host, and entire path from source to destination you will go to find, and you will forward the message or the packet to the destination based on its address. We call it as routing. So these are all the things that we certainly, when you start looking into the transmission, there are three types of transmission. We call it as unicast, broadcast, and multicast. So unicast, one to one, broadcast is to one to everybody, and multicast is one to selected persons in the network. So that is what you call it as multicast. Now further, we move on to the cost-effective resource sharing. I already told the requirement in order to build a computer requirement. We have listed all those components. Cost-effective resource sharing is also one of the component. So if you have a link, that link has to be very efficiently used. So cost efficiently used. So this concept, we call it as multiplexing. So where multiple people are accessing the same shared resources among multiple users. So you can see it's a system of resources that is being shared among multiple users. Multiplex is a way of sending multiple signals or streams of information over communication link, and of course in the same time. Okay, so here what happens, there is only one link. It has been shared by three computers, and which is shared among a switch. One is transmitting at the switch 2. What happens, demultiplexing happens. So their respective packets will be sent back to their respective destinations, receiving stations. So this is what you call it as. There are three types of multiplexing: frequency division multiplexing, time division multiplexing, and statistically frequency division multiplexing. So statistical time division multiplexing. So first, let us look into time division multiplexing. So what happens in time division multiplexing? You consider there are four nodes A, B, C, D, and So at a given interval of time, what happens? The link will be enabled for A for first second, second for B, third second for C, fourth second for D. So A, B, C, D can transmit the data. And in the next 4 seconds, again, A will be first second, B will be second, C will be third second, D will be the fourth second. Suppose if they have the data, they will transmit. If they don't have the data, that their time which is allocated will not be utilized. So what happens? It is not being used. So this is one of the biggest problem of synchronous time division multiplexing. Even though other stations have data to transfer, since the time is allocated to station B, B doesn't have any data to transfer. The entire 1 second is being not used, idle, and allocated, but it is not used. What happens? The entire link become wasted. It will not be used at all. So that is another very important thing. So time slots are not being used. So that is the biggest problem. So disadvantage. The channel capacity cannot be fully utilized. Some of the slots go empty in certain time of frames. The capacity of a single communication line that is used to carry various transmission should be greater than the total speed of each input. So in order to overcome this, we have frequency division multiplexing. In frequency division multiplexing, each station is given a different frequency to transmit. So imagine there are 3 channels, 3 stations. 3 stations will transmit at frequency 1, F2, F3. So if they have data, they will transmit. So there will not be any problem with the transmission. But if one particular station do not have any data to transmit, so what happens? In that frequency, entire frequency bandwidth is wasted. So even though it is allocated, it is wasted. There also, even the time is allocated, time is not being used. Here, frequency is not used. So the better solution that what we see is statistical multiplexing. Look at here, statistical multiplexing, synchronous multiplexing. Suppose imagine A is having 3 packets, A1, A2, A3. B is having B1 and B2. C is having C1 and C2. So what happens initially, if you are not using a time division multiplexing, A will be sent, B will be sent, C will not send, because there is no what you call it as there is no packet here in C. C does not having packet, so this will go empty. So it is unutilized. It is unutilized. In the second slot of frames, A is having second frame, B doesn't have any frame, so gone. So B also not sent any packet, so unnecessarily it is wasted. Yes, gone. Only so in third slot it is being used. So this is the major problem that we are having. This is a major problem that we are having with respect to time division multiplexing. So we go with statistical time division multiplexing. If all the stations are having A1, B1, C1, so you can see A1, B1, C1, and D1 is allocated to the next one. Next A2 is there, and since you don't have